Okay, so I'm describing the processes of transcription and translation. Basically, the big picture of these is they're just two parts of making a protein. So it starts with transcription, which is going to happen in the nucleus of eukaryotes. So there's three main parts: the initiation, elongation, and termination. So it'll start with initiation, and so that's basically when you have your DNA strand, and then within your DNA strand you have your transcriptional unit, which is the part that's going to be transcribed, obviously. So within your transcriptional unit you have your promoter, or that's where your TATA box is, and that's where it's going to start. So you have something called transcription factors, and they find the promoter, and then they signal the polymerase to come, the RNA polymerase. So the polymerase comes and it attaches to that promoter, and that's initiation. So then we move on to elongation. The promoter will start unwinding the DNA, and it exposes 10 to 20 nucleotides at a time. And this is all happening on the template strand, by the way. So the template strand is where we're going to see the polymerase attached, and then the other one is the coding strand, or like the sense strand. So we're on the template strand, obviously, with the polymerase. It's unzipping the DNA and exposing the nucleotides. It's going to attach the complementary like mRNA nucleotides, or like the ribosomal ribonucleotides. And so it's going to attach U with A and G and C together. So it'll do that. It starts moving along the template strand, and as it's doing it and it's unzipping it, it's going to build the mRNA strand off of it, and that's why it's called elongation, obviously, because it's getting built. And then as it goes, it's also going to like re-zip back up the DNA strand, and it's going to keep doing this until it reaches the termination sequence of the DNA. And basically that's when elongation ends and termination begins. Then it's termination. Then basically, so the termination sequence tells the polymerase or whatever, the polymerase releases, and the mRNA releases, and then you have your new mRNA, and that's going to be in the cytoplasm, and then that's where transcription ends, and then we're going to start translation. So translation also has three parts: the same initiation, elongation, and termination. So we have our new mRNA, and that's floating around in the cytoplasm, and that's going to find the smaller subunit of the ribosome. So we have our small subunit of the ribosome, and then we're going to attach the tRNA, and we're also going to attach our did I say tRNA? I meant mRNA. We're also going to attach our tRNA, which is going to be charged with your amino acid. So basically, it's acetyl, is that what it's called? No, amino acyl tRNA synthetase is the enzyme that's going to bind the tRNA with its amino acid, and it's like it catalyzes it, so like a catalyst basically speeds it up. So we have our subunit, our mRNA, and then our tRNA, which is going to bind to the I'm blanking, it's AUG, it's the start codon of the mRNA. And then, so we have that, and then our top, the bigger subunit of the ribosome is going to come on top. So it's like a sandwich: subunit, mRNA, tRNA with the amino acid, and then the hat, like the big part of the ribosome, is going to go on top. And so it'll start with the tRNA in the P site, and so then a new tRNA will come in to the A site. The ribosome will form a polypeptide bond between the two amino acids. It's going to start the polypeptide chain, and then everything scoots over. The old tRNA goes into the E site, and it exits the ribosome. A new tRNA comes in, does the polypeptide bond, and it keeps moving like that until it reaches and that's elongation, until it reaches the stop codon in the mRNA, and that's when the termination will start. So the stop codon in the mRNA will call up the release factor, the release factor comes, it tells the polypeptide chain or whatever to release, and the ribosome releases, so then you have your full new polypeptide chain, and then that can get made into a real protein. And that's the process.